Dear viewers, thank you for your interest in our concepts for repurposing coal power plants. I'm Miroslav, Deputy Managing Director of SolEngCo, and I am pleased to present to you SolEngCo's concept for repurposing coal power plants into bulk energy storage. In this part 3, we will talk about the repurposing an existing coal power plant into thermal energy storage, which is one of SolEngCo unique concept and which propose highly efficient utilizations of surplus energy, offers a solution for storing energy in large scale, and has notably lower capital expenditures and operating expenses in comparison to other bulk energy storage technologies. Furthermore, this concept considers saving the high qualified jobs, the investment, and securing the electricity supply that shall allow utilities to remain the main players in power generation, not only on their domestic market, but also over the border. So let's start. Before we will talk about the repurposing theme, I would like to introduce to you the background for this project. SolEngCo team is a pioneer in the CSP industry, and we have practical experience in implementing thermal energy storages within the concentrated solar power industry. In this picture, you can see Gemma Solar concentrated solar power plant, which is located in Seville in Spain and was tested and put into operation in 2011. Gemma Solar is the first commercial solar plant with Central Receiver and molten salt energy storage, which is hidden somewhere here in the power block, and here is the solar receiver. Here are the mirrors called heliostats. They mirrored the sun irradiation on the receiver. In this picture, you can see the Andasol CSP plant. Here is the thermal energy storage that will be the significant equipment for this presentation. A few words about Andasol 1 CSP plant. It is Europe's first commercial plant to use parabolic troughs. You can see them here. And the first power plant used molten salt thermal energy storage worldwide. The plant is located in southern Spain near Guadix in Andalusia. The plant was tested and put into operation in 2009, so we have about 12 years experience in operating thermal energy storage within the CSP industry. If you need more information about this project, you are welcome to watch my presentations about performance testing at Andasol 1 at the link that appears now at the upper left corner. Let me describe the CSP industry in a nutshell. This is the slide. We can see the simplified process scheme of Central Receiver. The sun rays are mirrored on the heliostats on the receiver, where the HTF stands for heat transfer fluid, is heated and led to the hot tank. The hot tank, the cold tank, they represent the thermal energy storage, about which we will talk in this presentation. Now we will continue with the description of the flow diagram. From the hot tank, the HTF is pumped through the heat exchangers and cooled down and led to cold tank. Feeding water and steam are taking over the heat from the HTF, spinning the steam turbine and the generator, producing the electricity. Simultaneously, the HTF is pumped from the cold tank to the receiver, where it is heated up to the requested temperature, 565 degrees, and with gravity is falling into the hot tank. This closed the HTF loop. After the sunset, or when the sun rays or irradiation is not sufficient, this part of the loop is closed, so the pumping from the cold tank through the receiver. However, the pumping from the hot tank through the heat exchangers can continue till the hot tank is empty. So we can ensure the operation without the sun or without enough solar radiation whenever we need to generate the power. This technology is commercially proven, and up to now we have about 4 gigawatt CSP plants with molten salt thermal energy storages implemented worldwide. Now let's move cold power plants. Here we have simplified process chain of coal power plants implemented across Europe. Actually, we can say implemented across the world. We are starting with CO2, which is the greenhouse gas that shall be reduced to zero for all electricity generation by 2050. The flue gas coming from the combustion of coal into the boiler flows through the heat exchangers to the dust removal equipment, and then to the NOx removal equipment, and through a scrubber, leaving the plant through the smokestack. Here we can see a tray of smoke, which is visible when the plant is operational. Let us talk further in these presentations about flue gas cleaning and boiler. Here we have a boiler, including the fire, the transportation of the coal from some storage, definitely prior to that, transportation of lignite coal from the mine and the mine itself. Finally, we have here water steam cycle, including the heat exchangers, the steam turbine, the condenser, the cooling system with cooling towers, definitely the generator with all the switch yards and power evacuation into the electricity grid. What is not visible here is the entire infrastructure and all the auxiliaries to run this plant. So all this with the auxiliaries and infrastructure is the asset that we as an independent consultant are considering in our concept to be innovated and transform into a more efficient, environmentally friendly and dispatchable facilities that are meeting the political, social and technical requirements laid down by the EU strategies, EU directives, governmental strategies, as well as states' laws, and meeting the international and country standards and codes. Furthermore, in these presentations, I am pleased to introduce to you very briefly our suggestion for sustainable technical and economical solution for infrastructure use of the facilities and a development of the region for the favor of the stakeholders, employees, local government and public. And it has been already discussed at international conferences, and it is publicly known that bulk energy storage is desirably needed for grid stability and shifting energy in large amount from shoulder to peak operation. It is inevitable that an availability of low cost and scalable bulk electricity storage must be considered for use of green energy, mainly from wind and solar, in order to gain deep reductions in greenhouse gas emissions in power generation sector. In our concept, it is considered the decommissioning of the entire plant. Everything what you see here will be decommissioned. It is inevitable to dismount this part of the plant, including the gas cleaning technology and the boiler. And definitely all their auxiliaries equipment. Furthermore, the lignite coal mine, the entire transportation, storing and preparing the coal for burning will be not only dismounted, but they will be subjected to remediation and redevelopment. To this, it is necessary to mention that also ash pond and land filling will be a part of it. They are not shown here. So now, convert a coal plant to storage power plant. However, the steam cycle remains, as well as the other facilities like water intake, raw water and wastewater treatment, electrodistribution, switchyards, high voltage line, roads, rail tracks, etc., etc. Here we go with the existing water steam cycle cooling system, water steam cycle cooling system, power evacuation, and the existing infrastructure. We are proposing to build a thermal energy storage using molten salt as a heat transfer fluid. The molten salt is heated with the excess electricity from renewables and stored in a hot tank. The plant generates electricity during period of high electricity demand, and the power output can be easily regulated through the flow through the heat exchanger. The startup and shutdown of the plant is similar to all power plants equipped with steam turbine power generation. During the time when the surplus energy is available, the HTF is heated up to the requested temperature. As you can see here, is 600 degrees Celsius. Temperature is higher than D1, which was presented with the CSP plants. So this temperature is theoretically reachable, but not commercially proven. What we want to show here is that the range of the temperature for the steam turbine is reachable if you have a steam turbine for 565 degrees Celsius or even higher. We can adjust the tank for it. In the coal tank, it is stored molten salt. It is closed the heat transfer fluid loop. Such repurposing is economically interesting only when we can use the existing water steam cycle, the entire infrastructure, cooling system, water system, and so on. By utilizing existing infrastructure and equipment, significantly lowered the capital expenditures. All up, the operating expenses and capital expenditures will be lower in comparison to other bulk energy storage technology. However, this concept is based on already commercially proven technologies. Therefore, this concept noticeably reduces all types of risk, explicitly hazard risk, financial risk, operational risk, and strategic risk. Also, it is worth it to note here that this technology does not have any greenhouse gases. Thus, it is climate neutral and can be operated for long-term perspective of 30 and more years. The utilizations of the surplus energy from the renewables, alongside with high efficiency technology called chain, combined with the high degree in flexibility of dispatchable power, ensure that it is stability in the grid. This presented concept is technically reasonable and financially affordable solution for repurposing coal power plants and opening perspectives for coal regions in transition beyond the coal phase out. Our concepts are based on SolEngCo team experience in developing, implementing and operating emerging technologies around the globe. We hope that this concept innovates and triggers investment in environmentally friendly technologies with considerable use of governmental and EU funding. However, this concept may be suitable for certain sites only or for a number of sites, depending on different criteria like legal issue, technical issue, and market perspective. For this reason, this concept is not the ultimate solution for retrofitting, but it might play a significant role in highly efficient and economically feasible retrofitting of coal power plants. If you are interested in other our concepts, we will be pleased if you visit us at YouTube, LinkedIn, and SolEngCo website. If you are interested in our services, please contact us for initiating further steps. Thank you for watching.